And now let us take up some questions involving pulleys. So after that we'll have what they call as wedge constraints, when one body is on top of the other body. So I put up two situations on the board. Let's analyze this and do. Both are having just two bodies. One moves, the other one is going to move. Later on we'll be doing situations where we have more than two bodies, three bodies, and even more. So those will be more interesting to do. So here I've made the pulleys not symmetrical deliberately so that you realize what are the factors which are actually having an effect. You can consider whatever radius you want. You can consider this as R, this as 2R, this as say 4R. Then obviously this can be calculated, back calculated. So I'll make it even more, say 5R if required, and try to do this. So I'll give you some time for this. Take your time, take your while and do. By analysis, let us see the first method first. By analysis, it is all flat on the ground, no effect of gravity, nothing. All the wires, all the strings have to be tight. So I can move any one movable pulley and keep the other things still and see how much of the other movable pulley has to be moved so that the strings are tight again. So what do you want to move first? Say this small one is taken up by, so I'll redraw over here, so I'll not mess up the main diagram. By the way, sizes of the pulley is not going to matter. Once we are done with the question, you can analyze on that. If you have any doubt, you can ask me later. So by the first method, let me move this movable pulley up and not move anything else. So this has gone up, this point has gone up by say X amount. So what is created? There is a loose string which is over here which needs to be tightened. So if this has gone up, everything remains at the place. Then what we can do is either we can pull both the sides or one side. So suppose I pull one side by X. Is it going to make the string tight again? This is a loose string. No, we have to pull one side by 2x. If I pull one side, I have to pull it by 2x, so that I'm holding this side, I'm holding this side, and I'm pulling this by 2x. So the whole thing, this x plus x will get again tightened. So when this is pulled by 2x, how much will this fall? This is going to fall by x only. Why it is going to fall by x? Because a movement of x over here, requires x plus x, 2x extra string. So you have all this 2x goes into this x and that x. All this part is still held and it is remaining over there. The other way of thinking was, when I pull it down by x, then we have x plus x, 2x extra string to be supplied from somewhere. So where can that 2x extra string be supplied? If this goes up by x, again x plus x, 2x extra string it will supply. So what we are noticing over here is the dia of the pulley doesn't matter. This is a big pulley, there's a small pulley, but the movement of both the pulleys were x. So how much ever is the size of the pulley is not mattering, because whatever amount of rope is sticking to the pulley is still sticking to the pulley in later on situation also. And what matters is the side lengths, this and this. So here xx, and there also it is x and x. So the answer is this goes x up, then this goes x down. That is by analysis. If you are able to do that way, well and good. If not, then let us take all the sections, length of each section of the string, and see the increase and decrease and equate it to 0. So we say that body 2 has gone, okay, we were doing it down, so we'll do it down, sorry. Say we have this body 2 going down by y and this body 1 going up by x. So if the body 1 goes up by x and the body 2 goes down by y, and all the strings are tight, so what has happened to this section of the string? We'll take all the sections starting from say this section. So what has happened to this section of the string? That section has reduced in length by x amount, so minus x. What has happened to this section of the string? That section has also reduced, the pulley has come over here, the section has reduced by x amount, so minus x again. And this pulley has gone down. So what has happened to this section of the string? This section, it has gone from this point to some point over here. So this has increased. So how much is that? That increase will be plus y. Whatever was the earlier, plus y. Whatever. This was the whatever earlier. And this section has also gone down by y. So that is also plus y. So net decrease is equal to net increase. So decrease has been x and x, and increase has been y and y. So what we get? We get x is equal to y. That is your method 2. Now method 3. Okay, so in method 3, again, let me redraw very fast. So here in method 3, we will see the work done by the tension. So one can be thought of the input place, and one third can be thought of as the output spot. So tension here is up, tension here is also up. Say this goes up by x and this goes down by y. So the work done by tension over here is positive, over here it is negative. So how much is the tension? So let us consider this string. So tension in this string is T, 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 T. Any section of the string, it pulls both the ends. So you see, watch carefully. Any section, I'm drawing two. I'm not just drawing one tension line. Whenever you draw in a section, draw both. Pull both the ends. Even though the other end may not be required in a particular question, but put a habit of drawing both the ends. That's quite important. So what's the tension over here? 2T. As explained to you earlier, we'll consider the pulley as massless and all. And this is 2T. So downward tension and upward tension. The downward is 2T and upward is 2T here also, because this is up, up. So this down on the pulley is 2T. So this up is 2T. So what we have is the work done over here. This 2T was upwards, movement was upward. It is plus 2Tx. And the work done by the tension over here, 2T is upward, but the body has gone down by y. So it is minus 2Ty is equal to 0. So what you get is x is equal to y. So you do whichever method, you are going to get the same thing. That's for the movement of pulley. I can apply this also over here, but not required. Velocity of this and velocity of this and this, velocity of these two parts you can write. Supply of string over here. Okay, that would be interesting. I'll just write, I'll take the velocities as different velocities here and there. We'll see how it cancels out. So say this body is going up by v1 and these velocities are, say, u dash and u. So this part of the string is going up with u dash. So this part of the string would be coming down with u dash. This part of the string is going up with u. So this part of the string must be coming down with u, no doubt, because these two are fixed pulleys. So if this string is going up with u, this string is coming down with u. Now we have a relation between the movement of the velocity of this part of the string, this part of the string, and this point. So what's the relation? The relation is v1 plus v2 by 2 is equal to the velocity of the pulley. So if this is going up with v, velocity of the pulley is v1, is going up with v, so upward is positive. So u dash we have taken upward, u also we have taken upward. So what you get is u plus u dash by 2 is the equation at this end. Equation at this end would be this whole thing, say the pulley and this mass is going down with v2. So v2 is the movement of the pulley and these 2 points are going down with u and u dash. So again, say downward is positive, then the velocity of the pulley is v2 is equal to downward positive, downward positive. So this is both are downwards. So u plus u dash by 2 again. So what we conclude from 1 and 2 is v1 is equal to v2 in the directions what we have taken. We have taken v1 as upward direction and v2 as downward direction. So that is what we get the answer from here also, that the velocity will be same. That means the displacement will be same. So what have we done over here? We have not restricted the velocity of this to 0 and this to twice of v1. That is what I said with analysis, that you restrict one side and move it and see the movement on the other side. So had we restricted it to 0, had this u been 0, then u dash would have been twice v. You can see from the formula also. So here we are not restricted and we have given them any velocity they want to go at. So u and u dash, one can be negative also and the other can be positive also. We have given it full liberty of going with whichever velocity possible. It was not necessary in the two analysis cases. One is we restricted it, the other way of analyzing was we moved it and moved both the side by x amount up. Means velocity of v1 was equal to u and u dash. Means v1 was equal to v1 plus v1 by 2. is how we analyzed in one of the cases. In the other case, we analyzed by V1 is equal to 0 plus, say, the U dash by 2, where U dash was 2U. So we have analyzed using these, and here we are letting the velocity to assume whatever value they want to be and using the formula which cannot be defined. So again we get V1 plus V1 is equal to V2. So how we have done by all three methods. I would prefer analyze and just be over with these kind of simple questions without having to write anything. And even if you have to write, this method 2 is the minimum effort method, so you can put that. And for work done, that is also quite fast to write, but then you'll have to put all the t's before you start with the question. So you have to put the t's properly, assume all the pulleys are massless, and that is how you get to the work done method. And obviously this method is just to get your understanding of relative velocity right, so not necessary to be applied in this particular case. So moving on to the next case. So again, two bodies only. We have body 2 hanging from the small pulley and a body 1 which is attached at 3 spots as shown. Now again, you can have the movement whichever way. Which is massive and which is not massive is not the question. If it goes up, this is going to go down, or if this goes down, it is going to go up, and the movement ratio will be the same. So we will move in a direction what we feel convenient. It is, the question may say that the body 1 was going down, so that doesn't matter. To solve the constraints, we'll assume the direction what we want and get the ratio of the movement, and then later on, whatever is the question, whatever is the actual question, we'll represent the answer in that fashion. Okay, so let me tackle this question with our first method, that is by inspection. Now I will always prefer to make the strings loose, so let me redraw this question first so that this diagram is intact. Yeah, so this is the diagram. This is body 1 and that is body 2. Say I move body 1 up. It is all, everything has been placed flat on the ground. What is going to happen is when I move body 1 up, due to gravity, it is going to go down. But here, I'm not letting gravity play any role, and whatever movement has to be done will be in my control. I'll do all the movements myself. So when I take this body up over, say, here, then what happens? This string falls loose, this string falls loose, this string becomes loose. Everything is flat on the ground. Now I'll move. So if I've moved this body up by x, this loose string what we get over here is x amount, x amount, x amount. Now one by one I'll tighten it up. So to tighten this part up, I'm going to pull this part down by x amount. So I'm just tightening this loose string, I'm just tightening it up and it becomes tight again. So this part has to go down by x. If this part has to go down by x, then I have to move the pulley. I have to move this pulley down by x. So the pulley goes down by x amount. If the pulley goes down by x amount, again I get some loose strings. I'll get loose string over here, I'll get loose string over there. So I put the pulley down. By the way, I'm not letting gravity do any effect. So I put the pulley down by x, so I get a loose string of x amount over here and x amount over here, because the pulley itself have moved down by x amount. So now let me see how much loose string I had. This part has become tight, so no doubt about there. I've got loose string here, I got loose string here, I got loose string here, I got loose string here, and the pulley is down somewhere over here. So what I do is I'll just tighten this part up. So to tighten this part up, I'll have to pull this down with 3x. X to tighten this, x more over here. So 2x from there and then x more over here. So down there I have to pull 3x to make this part of the string, this string again tight. So this string has again become tight, this string has become tight, but here we have got a big loose string of 3x. Now how to manage that 3x? This pulley has to be pulled down by 3x. So this part, the pulley goes down 3x, so that this loose string, the loose string what happened over here is again tight. But mind you, I've got a loose string of x also over here. So the situation, I'll just redraw the situation over there. This was the initial situation where the pulley was at a certain position in green. You had a loose string X over here and the body hanging down. Now you have made the pulley go down by 3x because you had a big time loose string over here of 3x. So you have made the pulley go down. To tighten this string, to tighten that string, you have made it go down by 3x. So once you have made it go down by 3x, what you see is this part also becomes loose, that part also becomes loose. So you have 3x loose over here, you have 3x loose over here. So how much shall I pull this end down so that everything becomes tight? So how much shall I pull this end down? So to make everything tight, I have to pull x plus 3x plus 3x. So the whole string which has to go down is 3x plus 3x plus x, which is 7x. So that's your answer. If this goes x up, this goes 7x down. Hopefully by other methods we get the same answer. So I'll just repeat this method before we go on to the next one. This method, we first made all the body flat on the table so that gravity is not acting. We moved body 1 x amount up and inspected how much loose string we got. We have not moved any pulleys yet. So we had got 3x loose strings, x here, x here, x here. So we planned to tighten this string up first. So we tightened this string up. So to tighten that string, this had to move down. So this pulley moved down by x amount. So what we got is x loose here, x loose here. That is this and this. X loose here, x loose here. X already loose over there. So to tighten everything up, x plus x plus x, we have to pull this part. We have to pull this part down. So we have to pull that part down by 3x. So when we pull that part down by 3x, what we got is 3x loose and x which was loose from the first movement. From the first movement we had got a x loose over here. So we have x plus 3x which is 7x. So we have to pull this body down by 7x, and that is how we get the answer. Without putting your pen to paper, without marking all these, you can do it in mind. You can just analyze and do it in mind when you have got a hang of it. Before you are sure of getting analysis right, you can go on for more mathematical methods where you can verify your answers or make them your pet methods. So going on to method 2. So shall I show in the diagram itself? I'll show in this diagram. When this body goes up by x amount, this body goes down by y amount. So I already know that y is multiple times x, so I'm just making that arrow as a big arrow, but you might not be knowing that before you do it. So hence you should have an analytical mind over here so that you analyze which movement is more. If you get the movement of this body as 1/7 the movement of that body, means your brains in physics is not working the way it should. Now, if this body goes up by x, we'll count all the string lengths individually. Length of each section of the string and equate it to 0. So we have got 3 strings over here. We have got this number 1 string, number 2 string and number 3 string. So first, using number 1 string, this goes by x up. So this pulley has to go down by x. So that's it, minus x, and this pulley goes down by y. So you can write plus y. So minus x plus y is 0. Now, if this goes down by x, what has happened to this section of the string? What has happened to this section? I think I'll have to redraw this part so that you understand it well. Okay, so now a bit safer method for many of you. So that is counting the reduction and increase in length of the string. So we have got 3 strings over here, one in green, one in orange and one in purple. So when this body 1 moves up by x, we are guessing this is moving down by y amount. So what is happening to this green string? So I'll write a separate equation for green, separate for orange and separate for purple. That is how I'll be super safe in doing the question. So what has happened to this section? It has reduced by x, the green string, and this section, assume that this pulley goes down by some amount, say p. We don't know yet how much. Okay, so it goes down by p, and eventually this pulley is going to go down. So they say this goes down by q amount. So what has happened is the green string would have increased, the pulley has gone down by p, so the green string would have increased from here to wherever it goes by amount of p. So we get minus x plus p is equal to 0. So we know what it means. It just means that how much ever the body has come up this side, this pulley is going to fall down the same amount. So it goes down, goes up x, so it goes down x. So P is equal to x. Now here, so I'll instead of P, I'll be writing x. I'll write P and then later replace it by x for the next string. So in this orange string, what has happened? It has gone up this point, the orange one. So this point has gone up by x. This point, this pulley has come down by P. So this point has come down by P. So this section has been reduced by x plus P. So it has been reduced by x plus P. So minus x minus P. That is how it has been reduced. What has happened to this section of the string? Now this part has gone down by P. So this has gone down. So this section has reduced by P because the pulley has gone down. So this point has gone down by P. And this point, the other end where it ends, that point has gone down by Q, which is increasing the length. So it has increased the length by Q amount. So what we get over here, remember your P was equal to your X. So what we get over here is Q is equal to X minus X minus X on the other side. So minus X minus X. So that is your 3X. So that is what we had done through the analysis also. This is going to fall down by 3x. Now the last string, the purple one. Now this pulley has gone down by Q. This point in the purple string, we are going to analyze the length of the two sections. So this has gone up by x, but the pulley had come down by Q. So the remaining length is x plus Q shorter. So it is minus x minus Q. X up and Q down. So it has reduced the length of the section by x plus Q. The other section has also reduced because the top point has come down by Q amount. So it has reduced by Q, but the bottom point has gone down by Y amount. We are assuming it has gone down by Y amount, which is a correct assumption. So it has increased the length by Y. So what do we get from there? Remember, your Q's are equal to 3x. So 3x and a 3x and a x makes it 7x. So we get y is equal to 7x. So thankfully that answer is same as what we had got earlier. So we have this y is equal to 7x. So that's your method 2. So we have got method 1, we have done method 1, we have done method 2. Just give it a go and do the method 3 yourself. And then if you are wanting to write the relative velocity equations and all, you can write that equation also and verify what is happening over here. Not required. Obviously all methods are not required. Why am I telling you in all methods is whatever suits you best, do that method. So I'll just quickly do the work done method also over here. So all strings will have different tensions. We will assume ideal pulley. So say this string is having a tension of T. T up, T down, T up, T down. Every time I'll make both the T's pulling both the ends. So this becomes 2T up, 2T down, 2T down, 2T up. So this is 2T, 2T. This pulley is massless. We are assuming it is massless. So the tension in this green string becomes 4T up, 4T down, 4T down and 4T up. So let's see what is the work done by the tensions. So one is the input end, one is the output end, whichever end you consider. The work by the tensions. So tensions, the total work done by the tension over here is the total tension force over here is 4T plus 2T plus 1T. How much is that? So I'll write in blue. That is your 4T plus 2T plus T. That much, all of them is this totally is a total force on this, and all of them have moved by x amount. So the work done by this force totally is x, so much into x. So that's the work done at this end by the tensions. What's the work done over here? Mind you, just note that the direction of the tension and the direction of movement is same. Hence we have written plus over here. And on the other side, the tension is up, but the body has gone down by y. Hence the force is minus T. T was the tension over here, and y is the movement. They are opposite in direction, so minus T y. So total work done by tension will be equal to 0. What we get over here is 7T x minus Ty is equal to 0. Again we get your y is equal to 7x. So again quite a safe method over here. So if you ask me, I would prefer method 3 over method 2 in this particular case to be safe with the answers. So this becomes my preferred method. But generally I will analyze first and get my answer. I'll get a feel of what's the answer. If you're not very sure, you can go for a hunch and then do these methods. Okay, and the day your hunches are going to be right, spot on, you can understand that you are good in this section of physics, in the mechanics. Now the last one, so I'll call these velocities, P as velocity and Q as velocity in this case, and I'll just do it again. So we have to write the equations of the pulleys. So equation of the pulleys, so say we are not going to write equation for this pulley, because we know that how much ever is the movement up, that's the movement down over here. So what's the velocity of the pulley over here? So here this is going down, this has come up with x, so this point is going down with x. So this pulley has got a movement of x. So applying that formula, it is x down. Say down we take positive. Now what about this end? What is happening to this end and what is happening to that end? So this section has come up with x. So this section, since the wire is always tight, this section has come up with x, and since the string is always tight, this will be going up with x. So one side is going up with x. So V1 will write it as minus x because it is going up with x. So what happens to the next section? What is happening to the next section? Say it is going down. Say it is going down with a new variable, say a. So this part is going down with a. So what we'll take is plus a, plus because down we are taking positive, divided by 2. So what we get over here is 2 into x plus x, which is a is equal to 3x. Thankfully, we knew that it is going, if it is coming up with x, it is going to go down with 3x. So this part now, we know that this part now, this pulley now is going down with 3x velocity. All these are velocities now. I'm just not renaming them. So x is the velocity, y is the velocity. I'm not renaming them. So this has gone down by 3x. So again apply the pulley formula. 3x is your pulley velocity is equal to velocities of the string on the either sides. So this has come up with x. If this point has come up with x, then this point must be moving up with x because it's a tight string. It is all the things are going together. So this was going up with x. So this point must be going up with x. Same logic as I used over here. This point is going up with x. This point is going up with x. So x up will take as negative because 3x down was positive. Plus, I don't know the velocity of this part, so I'll call this part velocity as say b. So what do I get over here is plus b divided by, so down is b, down we have taken positive, by 2. So what do we get over here is b is equal to 2 into 3x, which is 6x, plus x, which is 7x. So b is 7x and b is directly linked to this. So your y is equal to b. That y is equal to b. If this point is going down with b, then the body is going down with b. So we get b is equal to 7x. So this is more for fun. You can check out it is all coming right or not. So we have done by this method also, but not required obviously. So I would suggest you do by any two methods, and if you get the same answer, then you would be damn unlucky if that's not the answer.